All right, let's try a couple of problems from the handout. We all know Snell's law, n equals sine I over sine R. And you have to remember that that was derived for going from fast to slow. Well, let's take a look at the first diagram. We're going from fast to slow. That's good. So we have the large angle out here. It's not going to go straight. It's going to bend toward the normal. And now we have to calculate that angle. We're going to put in an index of refraction for water, 1.33. And that's going to be equal to sine on the fast side, 70 degrees, over sine on the slow side. I'll just call that the refractive angle. And we're going to solve for R. I take the calculator, 1.70 sine divided by 1.33 inverse sine. I get about 45 degrees. And that is what we were expecting because the angle is smaller than the incoming angle. All right, let's try this guy over here. Which way do you think the light's going to go now? We're going from glass into vacuum. A. We're going from slow to fast. We're not going to go straight. We're speeding up. So we're going to bend away from the normal. Again, applying Snell's law, we're going to use the index of refraction for glass. Sine on the fast side, and that's the one we don't know. I'm going to still call it I. We pretend the light is just going the other way. Sine on the refracted side, that's the slow side, that's the 25 degrees. Fast to slow. Even though the light's going this way, we just make believe it's going the other way, get the same path. What is the angle we're looking for on the fast side? And I get 39.3 degrees. Again, that's bigger than that angle, and that's what we were expecting. Okay, let's see what happens over here. We've got the light going from water to a vacuum. Again, it's going from slow to fast. So you would think that it's going to go straight. No, it's going to bend away from the normal. But you got to be careful about this angle. Kind of large. Let's try something. We could say 1.33 equals sine on the fast side, which is what we don't know, over sine on the slow side, and that's the 55. If you try to do this on your calculator, you're going to get an error. What does that tell us? We're beyond the critical angle. Now you could solve for the critical angle. You could say 1.33 equals 1 over sine of the critical angle. If you don't understand this, you should go watch the other YouTube video where we explained it. And the critical angle is 41.8 degrees for water. Well, we're well beyond that. If we're beyond the critical angle, that means the light is not coming out. It's just going to reflect. And you get total internal reflection. This angle is the same as this angle right here.